Hi, I'm Jared Lamar. I'm a senior at Oakland Tech, and I'm going to UCLA next year. Plan to study physics, which does use a lot of calculus, so this is stuff I need to remember, I guess. Um, let's see. I like to play tennis, read books, watch TV, play piano and guitar, and that's me. I might not. Okay, ready? If you want to take the limit of a rational function as x approaches infinity, here's what you have to do. If the degree of the numerator is bigger than that of the denominator, limit as x approaches infinity doesn't exist. And if the degree of the numerator is the same as that of the denominator, limit as x approaches infinity is the ratio of the leading coefficients. And if the degree of the numerator is smaller than that of the denominator, limit as x approaches infinity, 0. That's also known as the horizontal asymptote of the line. Alright, so as you just heard in the song, the concept I'm going to be focusing on with limits is how to take the limit as x approaches infinity of a rational function. And this is also called the horizontal asymptote. So, for example, this function, 3x cubed minus 6x over x cubed, the degree of the numerator and the denominator are the same. So what we're going to do here is take the ratio of the leading coefficients. So that's going to be 3 over 1, which is just 3. So therefore, the limit as x approaches infinity of this function is just 3. All right? Now with this function, since you have a squared term on the top and a cubed term on the bottom, the degree of the denominator is larger than the degree of the numerator. Therefore, the limit as x approaches infinity of this function is just going to be 0. For this function, as you can see, the degree of the numerator is larger than that of the denominator, and therefore the limit goes to infinity. Or another way of saying that is that there is no limit. So one concept we studied within derivatives was a method for taking the derivative of certain functions called the chain rule. So with this function, you couldn't just use a normal power rule because of the sign x inside of it. So what you need to do with the chain rule is first take the derivative of the inside, which in this case is cosine x, right? And then multiply it by what you have left derived. So in this case, it would be times 4 times sine of x cubed. So as you can see, so that would simplify to 4 cosine x sine of x cubed. So that is an application of the chain rule. As you can see, we took the derivative of the inside function and took it outside, and then derived the function normally with the power rule. So that's how you do that. This cartoon is a pretty good representation of the chain rule. If you imagine a pregnant woman where the woman is a function and the baby is a function inside of that function, basically you would differentiate the outer function, or the pregnant woman, leaving the baby still inside, and then differentiate the baby and multiply the two. And that's a good way to think of the chain rule. So the last major unit we studied in calculus was integration, and a major part of integration was U substitution, which is a process that helps you integrate certain expressions that don't seem like you can integrate them on the surface. So with U substitution, what you want to do is take one of the terms in an expression and call it U. For our purposes, we're going to use cosine of x as U. So U equals cosine of x. I'll get into why we chose cosine of x a little bit later. But essentially, right now, what we want to do is derive this so that we have du dx equals sine x, and then we can separate the variables so we get du equals sine x dx. So now, if we look back at our original expression, we do see sine x dx, so we can replace that with du. And we know that cosine x is u, so what we end up with is integral of u du, which, as you know, is just ends up being u squared over 2. Now we just plug back in what we used for u, and we come up with cosine squared x over 2. And don't forget plus c. So the reason we chose cosine x in the first place was that I knew that the derivative of cosine sine x appeared in our original expression, and we would be able to cancel it out by doing a u substitution with cosine x. So in general, with a u substitution, you look for you look for a term that, when you derive it, will cancel out something in the original integral. I've written a little poem about u substitution just to help people remember the steps. It's a little corny, but whatever. To do a u substitution is not a process so dull. It begins with choosing a value for u based on the integral. You want to choose a u whose derivative cancels out a certain part of the integral that you are worried about. After choosing a u, you derive it handily and replace the dx with the du and integrate dandily. After integration, you're really almost done. You put back the initial u value, a process that is quite fun. This process is used by many to help them integrate well, so pass this on to everyone. Be sure to show and tell. So in terms of advice to future calculus students, words to the wise, if you will, I think one of the more important things is that you remember that calculus is just math, like all the other math you've taken. I know when I came into calculus, I thought it was this brand new thing that would be unlike any algebra or pre-calc I ever took, but I don't think that's the case at all. I really think it's just new processes to learn, but it's the same fundamental thinking, and really the basis for calculus, which is, instantaneous rate of change, you can kind of see algebraically, which you go over at the beginning of the year. So don't come into it with so much trepidation. Other than that, just remember to study, do all your practice problems, and in general, just pay attention in class, and you should be fine in calculus. Because, like I said, it's just math. If you were good at math earlier, you'll be good at calculus. So, and the other thing is, don't give up if a concept seems ridiculous. I know there were a few times, like with partial fractions for me, where I felt that there was just no way I could ever learn this concept. And then it turned out I got it like a week later, so just stick with it.